Hello and welcome back to another episode of Making a Computer in Minecraft. Today we're going to be focusing on making our input and also talking about some funny little computer concept called registers, which we'll be using in our design. I am goofily really proud of this thing that I made here. It's just so I don't know. The only problem is that there's not really a way to turn it off. The only real option is, this one turns off. I can turn off the slime block, but everything else just kind of goes, so we're going to have to break a few of these. Now, before we can get started with anything involving inputs, we need to talk about this component that I designed a little while ago. I think I called it the memory accessor, but a better name is the data flow controller. What this does is essentially we have some data over here in storage, okay? And currently our output, which is just taken from the storage, is nothing, because we haven't chosen which byte of data we want to access. Now we select that with these levers here. So for example, if I want this data to be the output, I have to flick the lever, and that is now my output. That is the data that I have sent on. To better explain this, we're going to visit our old computer, God rest his soul, where over here we can see that we had the same storage access concept. So right here we have a very, very tall version of the same thing. And this green wire is our output, or all these green wires. And the orange wires are stored data. And as you can see here, we used this panel here to select which we wanted. Now you might notice that there are actually 8 pieces of storage here, but there are only 3 levers for our selection. And that is because we're treating these 3 bits as part of one number. One 3-digit binary number. If you're wondering why I scrapped this whole design, then go watch my video, I think it was 2 videos ago, episode 9. But essentially we're going to be using this very similar system now over here with our new computer. I have determined that white will be the color of our input. And this is going to be our inputs. Now, I know it doesn't look like much right now, but this should allow us to do a lot of stuff with our computer up here. For those of you who watched the episode 9, this next part may look a little bit familiar, because we're going to construct a very similar system as to what we had then, but now for 8 bits instead of just 2. Just realized I forgot the most important part of this entire system, which is the save button right here. And that should work right there. I've constructed the system for the first option here, but this is what we really want to look at here. This is the size of one byte save. Really just this. This is just the output being wired elsewhere. This is the size of it. That's all it is. Now for comparison, this is the size and complexity of one before. This is the size of one. All of this, and a little bit more underneath. And now ignore the green and the white, but still, the red, the blue, and the orange was just 1. So maybe now you're starting to see a bit of why I restarted the entire project, which, this is part of it, but this is another very big part of it. How much smaller we can make everything, and the smaller things are, the more we can accomplish with them. And now we're going to use the incredible/clone command to make 8 more of these. Maybe even 16, I'll think about it. Now everyone, I need you to pray that this works, otherwise it's going to be really annoying. That was definitely the least annoying of the annoying possibilities. From what I can tell, we just need to do it here. Let's go! Again, for comparison, this is how big that was. in the old system. So let's just super quickly make sure the system is armed, which we can see down here it is not. The default state for the entire system is for it to be saved or locked. I'm going to refer to it as locked from now on, because essentially what that's saying is don't change what's stored here. We only want to change what's in there when we save something there. Oops. So by default, these all need to be on. Good. Now the part of this that we're still missing is our keys, which will be handled on the white wool. After some rewiring, I think we have everything in a good place, so we can start building our first key. Now I'm going to build one of them on camera and explain my process, so that you have a general idea what's going on, but I'm going to build the rest off camera because they're just really not that entertaining, because the concept is pretty simple. So what we're going to do is we're going to start off by making sure that our redstone line continues unintruded. So we can check it here, but then whatever came in will continue afterwards. So let's just super quickly do that. Okay, so now, what are we checking for this key? Well, the key is 000. So we need to check if this one, and this one, and this one are all not on. So how we would do that is we want to check if this one is not on, and this one is not on, and this one is not on. So we check if this one and this one are both not on. Like that. And then we also need to check if this one is not on. So we would just do like that. Sorry. We just do it like this. Target block needed. And now we have our output. We now, right here. So this redstone lamp will only turn, this redstone torch will only turn on if all three of these lights are off. So we're going to need to do a little bit of rewiring, but that is our key done. So I just quickly reconfigured it so that it fits into a smaller space. And now we just run that right over here. And we make sure that it's low enough down. Like so. So that it passes underneath the orange and the green, which will soon be going up. But yeah. So now we can see that this redstone reaches this AND gate over here, meaning that right now, if we click the save button, which is currently a lever, but if we flick it, the AND gate is satisfied, and, well, actually I'm just going to show you. I'm going to show you with the button what will happen. Yeah, so now with this button, when you press it, it will briefly, you can see it flash there, it briefly allows the data from over here to enter, and then flashes back locked again, saving that data. So yeah, I'm just going to construct up all of the rest of the ones because it's a pretty simple system, as you can see. And so yeah, see you soon. Little progress update here. I just wanted to point out how tiny I made this one. 1, 2, 3, 4 blocks wide. I mean, it's really tall, but this was some ingenuity right here. I gave myself far too little space. You see this ugly mess? You see this disgusting mess right here? That is it working. Let's go. So now hopefully we can get a good showcase of what's going on here. Okay, so ignore the green for now. We'll get to that later. But let's say we want to store some data, like 101. Just that, or some zeros. And we want to store it at the second storage spot. So this is the setup. We click save. Let's go see if it worked. It did not. Alright, let's try that again. We want to save it at the first storage spot. And go. Let's go see if it worked. And it did. You can see this one's on and this one are on. We made the key system work. Woohoo! That was probably really loud. Now the glory of this system is that not only can we use these keys to specify where we want to save, but it can also be used to tell where we want to extract data. I've already talked about this in episode 5. That's basically where we are in progress right now, episode 5. But we're going to implement that here super quickly, and I really hope we can do it because I don't know what we're going to do if we can't. It's a little cramped, but you can see that if the key works, if the key matches the input, then it will also extend these pistons, which will allow that data to flow through. So that one was slightly wrong, but now we have it all fixed. But yeah, you can see that when it's 0, 0, 0, when that is our selection, then that is the data which flows through. So right now the key is 0, 0, 0, and so the 0th output, the 0th storage goes out. But if we switch it to anything else, then it is not let out. I've found a very strange, possibly horrible bug. So look up here. When this is powered, that extends. Okay, but there's nothing powering it. The redstone is running right past it. But then over here, it doesn't do that. So what is causing that? Hold on, my only idea is that it's something to do with the redstone torch placement. So like if we have this instead, maybe this will be fine. Okay. Okay, I think it'll be fine. I think it's just... Okay, I don't know what's causing it, but I think that we'll be okay. Oh, I built it wrong. Did I? Wait. Did I build all of them wrong? Did I build any of them wrong? I just placed this one wrong. Never mind. And here is all of the extractors fully set up. So you can see currently, storage 0 is the output. But if we switch it to storage 1, then storage 1 becomes the output. And so yeah, we have our... We're essentially back where we were before. Like everything that's over there, that is where we are now, but way smaller and way better. I mean, just one more time, we're gonna take a comparison really quickly. So here's the new one, and here's the old one. And these accomplish roughly the same thing. But yeah, looks like we're pretty well adjusted to our new home. We've gotten back to all of the progress that we had before, and I'm very happy that we decided to make this decision. If we ever feel lonely, we can always just look over at our old friend Joe and reminisce about how much worse he was. But yeah, thank you guys very much for watching. I hope you have a good day. Bye-bye.